All right, welcome back to part 9 of the Masterclass Explainer. Today we're cutting right through the noise to focus purely on a brilliant piece of engineering. If you're a fan of elegant, simple solutions to ridiculously complex problems, you are going to absolutely love this one. Our goal today is to see exactly how a protocol called Flow X402 manages to bypass an entrenched 30-year-old internet problem, and it does it using a radically simple engineering philosophy.
So, let's just start with this cold, hard number, 30 years. I mean, think about that. That's 3 decades where the internet's native payment status code literally just sat there completely dormant and unused. When the web was first built, the creators knew we'd eventually need a native, built-in way to pay for things. But the infrastructure just wasn't there yet, and this massive technical wall went up. And the craziest part? The biggest tech giants in the world either entirely ignored this wall or totally failed to scale it for 30 whole years.
Okay, here's our roadmap for today's explainer. We're going to hit the HTTP 402 fracture, look at the Ricarian complexity trap, check out the chopsticks design, map out the X42 webhook architecture, and wrap up with some real-world physical execution. Let's get to it.
Kicking things off with Section 1, the HTTP 402 fracture.
Look at this timeline. It's honestly kind of mind-blowing. Back in 1996, internet pioneers like Tim Berners-Lee actually reserved the HTTP 402 status code. Why? Because they totally saw a near future where native web payments would be a thing. By 98, WebDAV explicitly solidifies it as payment required. And then, crickets. Literally nothing happens. It's astonishing, right? This foundational piece of web architecture just gathered digital dust while tech giants failed to scale it. It just sat there empty until the X42 protocol finally stepped in and breathed life into it in 2025.
All right, moving right along to Section 2, the Ricarian complexity trap.
Now, you're probably wondering why the 30-year delay. Well, it boils down to this incredibly bloated engineering approach that actually caused the roadblock. For years, engineers were just obsessed with building these massive, monolithic, direct on-chain payment protocols. To put this into perspective, imagine trying to buy a pack of gum. But to do it, you have to bring a whole team of lawyers, draft a 50-page legal document, and get a notary to stamp it right there at the cash register. That is Ricarian complexity in a nutshell. By trying to bind incredibly dense legal documents directly to digital value transfers, they made scaling virtually impossible. A total nightmare.
Which brings us to the actual solution. Section 3, the chopsticks design.
So how does the X42 protocol actually bypass all that mess? It's all about an incredibly elegant engineering philosophy. Just look at this comparison. On the left, you've got the legacy approach, basically building a $1 million hyper-complex robotic arm. On the right, 2 simple chopsticks. I mean, you wouldn't build a massive robot arm just to pick up a single piece of sushi, would you? No way. You'd use chopsticks. They're simple, they're precise, and they get the job done perfectly. X42 applies this exact same philosophy. Instead of getting completely bogged down in heavy, bloated smart contracts, it just uses a lightweight, surgically simple application of tools we already have lying around, webhooks. It doesn't overcomplicate the transaction, it just cleanly connects the dots.
Let's break down how that actually works in Section 4, the X42 webhook architecture.
Okay, so here's how that chopsticks callback loop actually functions in practice to solve that massive 90s web gap. It's a brisk, highly deterministic 3-step rhythm. Step 1, the server doesn't panic and try to execute some massive smart contract. Nope, it just returns that classic 402 code, demanding proof of capability. Step 2, the client's wallet steps in and signs a cryptographic proof of payment. And then, Step 3, the client simply retries that exact same HTTP request, but this time it brings the receipt. The server verifies it and boom, instantly unlocks the resource. What you get is an immutable lock-in, bypassing heavy smart contract complexity entirely, achieved with true event-driven elegance.
But you might be asking yourself, who's actually pulling the strings here? Because it's definitely not a human sitting at a keyboard clicking a buy button over and over. This right here represents a huge architectural shift toward what developers call leaf node logistics. Basically, the human provides the high-level intent, sure, but an autonomous AI agent cell, which the documentation calls Polycretus, steps in and acts as a deterministic scripter. It handles the absolute deterministic sweat of the transaction natively, right out there at the edge of the network. It's high-fidelity execution, seamlessly guided by human mandate. Pretty cool, right?
And that brings us to our final piece today, Section 5, Real-World Physical Execution.
So, how do we bridge all this abstract digital logic straight into physical reality? Well, meet the Flow X402 cheerbot.
This was showcased in NYC in 2025. Now, on the surface, it just looks like a bright 3D printed desktop toy, but pop the HUD and it houses a Raspberry Pi. Acting as a physical switchboard, this little robotic vending machine takes that simple X42 callback and makes it physical. It reads a mathematically pure last-in, first-out, or LIFO JSON state tree just to verify the payment. And once it's verified, it sends electrical signals directly to the hardware's nervous system, the actual physical GPIO pins. The payment hits the webhook, the electrical pin triggers, and the bot physically reacts. It completely bypasses those heavy contracts entirely. It's just brilliant.
So we've just looked at a system that perfectly bypasses a 30-year technical wall, simply by swapping out bloated smart contracts for a surgical webhook architecture and deterministic agents. The magic here isn't an endlessly complex code, you know? It's really in the pragmatic orchestration of simple tools. So as you absorb the sheer surgical precision of this protocol, I want to leave you to ponder this final thought. If a simple callback can activate the internet's missing payment layer and let AI seamlessly interact with physical hardware, what other foggy, dormant corners of our digital economy are just sitting there right now, like a giant puzzle, waiting to be rescued by this exact, simple chopsticks architecture? Think about that for a bit. Thanks for joining me on this explainer, and as always, keep learning.